What if there was an asteroid heading toward Earth, and we still didn't know exactly how big it was? Imagine a space rock silently drifting through the void, only to be discovered just recently. Now, what if this same asteroid had a small, but real, chance of impacting Earth in the future? That's not just science fiction. This is the story of asteroid 2024 YR4. Discovered on December 27, 2024, asteroid 2024 YR4 is currently being closely monitored by astronomers worldwide. While calculations suggest that it has a 98% chance of safely passing Earth in December 2032, there's still a tiny margin of uncertainty, enough to keep scientists on high alert. And that's where one of the most powerful telescopes ever built comes into play, the James Webb Space Telescope. Unlike traditional observatories, Webb's advanced infrared sensors can unlock details about YR4 that no other instrument can, especially when it comes to determining its actual size, a crucial factor in assessing the real risk it poses. The question is, what if YR4 is much bigger than we think? Or, what if its orbit shifts just enough to change its trajectory? In this video, we're diving deep into why this asteroid is so important, how Webb will study it, and what this means for planetary defense. Stick with me until the end, because what we're about to uncover could change how we think about near-Earth asteroids forever. Not all asteroids are created equal. Some are harmless space rocks drifting through the cosmos, while others, like 2024 YR4, catch the attention of astronomers because they pass uncomfortably close to Earth. Discovered on December 27, 2024, 2024 YR4 belongs to a class of objects known as near-Earth asteroids (NEAs), space rocks that come within about 50 million kilometers of our planet. These asteroids are constantly tracked because under the right conditions, their orbits can shift over time, increasing the risk of an impact. Right now, the odds are strongly in our favor. There's a 98% chance that YR4 will harmlessly pass Earth on December 22, 2032. However, there's still a small margin of uncertainty in its trajectory, and that's enough to keep scientists focused on gathering more data. The biggest challenge? We don't know exactly how big it is. Current estimates suggest YR4 could be anywhere between 40 and 90 meters in diameter. That's a massive difference when it comes to potential impact effects. For comparison, a 40-meter asteroid could cause a localized explosion similar to the Chelyabinsk event in 2013, which shattered windows and injured over 1,500 people. A 90-meter asteroid would be closer to the Tunguska event in 1908, which leveled over 2,000 square kilometers of forest in Siberia. To make matters worse, YR4 will disappear from view in just a few months, making further tracking impossible until it reappears in 2028. That means time is running out to get accurate measurements. This is where the James Webb Space Telescope becomes a game changer. Tracking an asteroid's orbit is one thing, but truly understanding the threat it poses requires more than just knowing where it's going. The biggest uncertainty surrounding 2024 YR4 is its size, and that's exactly what the James Webb Space Telescope (JWST) is uniquely equipped to measure. Most ground-based telescopes rely on visible light to observe asteroids. The problem? Size and brightness don't always match. If YR4 is highly reflective, it could be small but shining brightly. If it's dark and absorbs more light, it might be much larger than it appears. This is why current estimates range from 40 to 90 meters, a huge gap that directly impacts how serious an impact would be. The James Webb Telescope solves this problem using a different approach: infrared light. Instead of measuring the sunlight reflected by the asteroid, Webb will detect the heat it emits. Since larger objects absorb and radiate more heat, this method provides a much more precise measurement of size. To do this, Webb will use two of its most advanced instruments. MIRI mid-infrared instrument measures the asteroid's thermal radiation, giving an accurate size estimate. NIRCam, near-infrared camera, complements the MIRI data and refines the asteroid's position and trajectory. So why does this matter? Because a 40-meter asteroid and a 90-meter asteroid pose completely different risks. If YR4 turns out to be closer to 40 meters, it's still a concern but unlikely to cause widespread devastation. However, if it's truly 90 meters, the impact could be hundreds of times stronger, causing massive damage over a large area. Webb's observations won't just give us a clearer picture of YR4. They'll also improve planetary defense strategies by refining how we detect and classify future asteroids. But when exactly will these critical observations take place? That's what we'll cover next. Time is running out. The asteroid 2024 YR4 will soon move too far from Earth to be observed, making these next few months critical for gathering data. That's why astronomers have scheduled 2 key observation windows using the James Webb Space Telescope, JWST. March 2025. This is when YR4 will be at its brightest, making it the perfect time for Webb to capture detailed infrared measurements. May 2025. A second round of observations will track how the asteroid's temperature changes as it moves away from the Sun. This data will refine size estimates and help scientists confirm final orbital measurements before YR4 disappears from view. But here's the challenge. Webb's observation time is extremely limited. The telescope is in high demand for studying galaxies, exoplanets, and deep space phenomena. So how did this asteroid make it onto the schedule? Every year, a small portion of Webb's observation time is set aside for Director's Discretionary Time, DDT, reserved for urgent, time-sensitive discoveries that couldn't have been planned in advance. A team of international astronomers, including experts from the European Space Agency's Planetary Defense Office, submitted a proposal arguing that studying YR4 is a matter of global importance. The request was approved, and now Webb will dedicate 4 hours to studying the asteroid, providing the most precise data ever collected on 2024 YR4. So, what happens after these observations? The collected data will be publicly available, allowing researchers worldwide to analyze the results and refine planetary defense strategies. But beyond the scientific implications, what does this mean for our planet's safety? In the next section, we'll explore how tracking asteroids like YR4 fits into Earth's long-term defense against space threats. The discovery of 2024 YR4 isn't just an academic curiosity. It's a wake-up call. While the chances of impact are low, this asteroid highlights a much larger issue. How prepared are we for a real threat? History has already given us warnings. In 2013, a 20-meter asteroid exploded over Chelyabinsk, Russia, injuring 1,500 people and causing millions in damage. In 1908, an estimated 50-meter asteroid leveled 2,000 square kilometers of Siberian forest in the Tunguska event. And those were small asteroids compared to what we know is out there. That's why tracking near-Earth objects, NEOs, is a global priority. Missions like OSIRIS-Rx, which studied asteroid Bennu, and upcoming efforts to explore Apophis are part of an expanding effort to monitor and understand these space rocks. But beyond studying them, the next step is defending Earth. So, what are our options if an asteroid actually poses a threat? Kinetic impact, like NASA's DART mission, which successfully redirected an asteroid in 2022 by crashing a spacecraft into it. Gravity tractors, using spacecraft to gradually alter an asteroid's path over time. Nuclear options, a last resort, but potentially effective for large, high-risk asteroids. While 2024 YR4 isn't likely to hit us, its discovery is a reminder that we must stay vigilant. If we ignore these warnings, we could find ourselves unprepared when a real threat appears. But what does the future hold? In the next section, we'll discuss what comes next for asteroid tracking and planetary defense, and why the James Webb Telescope is just the beginning. The study of 2024 YR4 is just one piece of a much larger puzzle. As we move forward, the need for better asteroid detection and planetary defense will only grow. The James Webb Space Telescope is playing a crucial role today, but future missions will take our capabilities even further. Upcoming projects like NASA's ESA surveyor will help detect potentially hazardous asteroids much earlier, giving us more time to prepare for any real threats. But there's still a lot of uncertainty. The 2024 YR4 asteroid won't be visible again until 2028, leaving scientists with lingering questions. By then, will we have new technologies that make planetary defense even more effective? Or will we still be relying on outdated methods? One thing is certain, the threat of asteroids is real, and while most won't pose a danger, it only takes one impact to change history. That's why continued investment in space observation is so important. The more we learn today, the better prepared we'll be for tomorrow. And now let me ask you, do you think we're truly ready to handle an asteroid threat? Could we successfully stop a dangerous impact? Or are we underestimating the risks? Drop your thoughts in the comments and let's discuss. If you enjoyed this video, don't forget to like, subscribe, and turn on notifications for more deep dives into the mysteries of the universe.